Okay, I'd like to finish up problems from 7 through 10. Um, so if we can turn to page 8. We did up to F, but I do want to do G on page 8. So page 8 says, take the definite integral of f double prime of 2x from 1 to 3. And what makes this look a little more difficult than usual is the fact that there's a 2x in here. So anytime there's a 2x or anything that's inside of the parentheses, this is a little bit of u substitution. Okay, so if we go through the substitution, we're able to handle that 2x that's inside the parentheses. So we're going to apply using use substitution to get that to look a little bit more manageable. That 2x tells us that there's something that we got to make sure to keep track of. Okay, so let me rewrite the problem here. All right, so if we want to go through your substitution, we know that to target the u value of what's inside the parentheses. We make our substitutions here. So we let our u value be 2x. du over dx equals 2. We solve for dx. dx equals du over 2. Okay. All right, so let's make our substitutions. Everything in terms of u. So this is why we go through substitution, so that we know what's actually hanging as a leftover. So we have to keep track of what in front. It's a 1/2. So that 1/2 is going to get pushed out in front. And there's something else we have to adjust. This is a definite integral. We do want to involve the bounds, but are the bounds going to be okay with this form? Okay, so I want everything in terms of u. So right now the 1 and 3 is in terms of what? X. So there's a mismatch in variable. So I'm going to go ahead and take the time to adjust the bounds so that not only is my integrand in terms of u, my bounds needs to be in terms of u as well. Because if I use the 1 and 3, that 1 and 3 is for the x, is not for the u. So I'm going to go through, convert the bounds. So that means if x is equal to 1, then we know the u is going to go through that little conversion. Right? So that's the conversion rule there. We know that u equals 2x. So therefore, u must be equal to 2 times 1, which is 2. So our lower bound, we need to convert from 1 to 2. So if x equals 3, u also equals 2x. So u equals 2 times 3, therefore what? 6. Okay, so I'm going to go back and change it from 2 to 6. Okay, so this is the problem that we're going to be working with. Now, if I take the antiderivative of f double prime, what's that going to rise up to? F what? F prime, right? So second derivative, I take the antiderivative, I'm going to move it up the chain to f prime. So therefore, my antiderivative is simply 1/2 f prime of u. Everything that we've done is already in terms of u, so I'm just going to involve the 2 and the 6. Right. Now, if this was a specific problem, let's say if it was like x squared, then you would go through power rule and then you would plug in upper lower bound. But because this is function notation, we just keep it in function notation, indicate the change with the calculus process, but then we also are going to involve the bounds. Right. Good so far. Okay. What gets inserted first? Which bound? Upper. Yeah, upper gets inserted first. Now, now we could do this another way. You could have this as a 2x, bring it back in terms of 2x, and then use 3 and 1. That's fine as well. But I do want us to practice converting the bounds because sometimes on the AP exam, they may just ask you what's equivalent to this, and the answer could just be this right here. Right. So I want us to get comfortable with that converting the bounds because sometimes your multiple choice question is forcing you into a problem, into a scenario where they want you to go through that conversion of bounds. Okay, so 6 gets inserted first. So 1/2 f prime of 6 minus 1/2 f prime of 2. Okay, so can we go any further? Are we able to find f prime of 6 and f prime of 2? Okay, what do we have available to us? The table. Yeah, so we go to the table. So f prime of 6 and f prime of 2. Okay, so 1 minus 1.5 is just going to be negative 1.5. Okay, we're going to see a lot more of these U substitution, but I want to kind of introduce the process that we can go through U substitution even if a problem is stuck in function notation. Okay, a couple of things that I want to go over from your homework before we do our next set of practice problems. So page okay. Page 9. Okay. Page 9, it was asking for you to find absolute max and absolute min. And you guys, went through, created your slope sign line, you pulled your critical points and your endpoints, and then you tested them. But I think the question that some students had was, this feels a little bit different than the process that we did. Right, yesterday we were just plugging into a formula and then we're getting the ordered pair. But now we're going through this process of this, initial plus displacement. So why is there that change? Why do we do EVT a little differently between the previous problem and this one? Because the previous one we just plugged into, we just plugged into this h of x formula, and then we can arrive directly at our answer. We didn't have to have that initial point. So this is what's the difference? Okay, if you go to page if you go to page 20, I have the key there. If you're given a derivative graph and then you're asked to find an order pair, there's two different scenarios that you have to kind of be aware of. If they give you a specific formula, and this is also on page 20. Page 20 is the blank copy. If they give you a formula for you to find order pair using antiderivative rule, then you just follow that rule. Okay, you don't have to do anything additional with that rule. But if they just give you a starting point, f of -2 equals 4, and they give you a derivative graph, then we have to go through this additional this formula where, okay, if I want to find a location, I need to have an initial position plus displacement. Okay, I need to start with that point that they give me, and then I have to add whatever is indicated on that graph. So we do have to involve the initial point if they don't give you a formula, but if they give you a formula like this, then you just use that formula. You don't have to use the initial point. Does that make sense? So just be aware that with a derivative graph, if they're asking for order pair at the function level, there's two different scenarios that's that we have to just be aware of. Okay, and then page 10. I do want to go through L'Hopital's rule and just kind of talk through that process. So I think there are some questions about it. This is on page 10, the bottom of the page D. So when do we do L'Hopital's rule and why do we do it? Okay, so if we see a limit problem that feels messy, the first thing we do is what? Plug in, right? So if it's a real number, you plug in regardless of whether it's a problem that you think you can do algebraically or whether it's something that is more complicated. But regardless, we always want to plug in, right? Because we don't know what's going on, right? Is there a real number? Is there a hole? Is there a vertical asymptote? We have to first establish what we're dealing with. Okay, so first thing we do is to just plug in the 2. So f prime of 2 over e to the 2 minus 2 minus 1. Okay, so f prime of 2, we have the graph above us, right? So what's f prime of 2? 0, right? But this is the f prime graph. So f prime of 2 is just the order pair. F prime of 2 is 0. So we get 0 over e to the 0 is 1 minus 1 is 0. Okay, now, is this an answer? Okay, this is sometimes students may look at this and feel like this means undefined or that the slope, that the limit doesn't exist, but this doesn't mean the limit doesn't exist. This means that this is an indeterminate form. This is incomplete. Now, if I got 10 over 0 or 8 over 0, then that means limit doesn't exist, right? So if I get like 8 over 0 or 10 over 0, a non-zero over 0, then the limit doesn't exist. Okay, so that's fine. What if I get 0 over 5? That's a real number. That's 0. Okay, and we can stop there. But if you get 0 over 0, that means there's something more that needs to be done. There's a hole in the graph, and there is a limit. We just are not able to see it at this moment. So normally before we would, factor, reduce, but we can't do any factoring, reducing with this. So we go through L'Hopital's rule. So L'Hopital's rule says, take the derivative of what you see in front of you. And once you find the derivative of the top and the bottom, then you're going to get a different version of the problem for you to evaluate the limit, and that will get you to your answer. So L'Hopital's rule, we do a limit as x approaches 2. And then we take turns taking the derivative of the top and bottom separately. This is not quotient rule, okay? And also, we're not finding the derivative of this expression. We're using the derivative feature to get to what we want to get to, which is the limit. Okay, so the derivative of the numerator, f prime, becomes what? F double prime, yeah. E to the u, what's the derivative for e to the u? E to the u times u prime, yep. So it's e to the u times u prime. So x minus 2's derivative is 1. Now, minus 1 is its own separate thing, so that's a constant, and constant goes to a what? 0. So minus 0, or just leave it blank. Now that you have a different version of the problem, now let's see if this will produce something other than 0 over 0. Okay, so 0 over 0 kind of gives us the green light to do L'Hopital's rule. So typically, we don't want to just look at a problem and do L'Hopital's rule without checking it. And also on the AP exam, they're looking for this step. They're looking to see, before you do L'Hopital's rule, that you're checking to see that there's a green light for you to apply L'Hopital's rule. So now we have L'Hopital's rule applied. Let's reevaluate our limit. We get f double prime of 2 over e to the 2 minus 2 times 1 minus 0. Right? What's f double prime of 2? That's the slope, right? This is the f prime graph. So f double prime is just the derivative. So what's the derivative of this? Oh, sorry, what's the slope of this line segment? 2. Okay, so I go up. Let's see. Up 1 over, let me see, is that 2? It's kind of hard to see. Sorry, yeah, it's 2. So, yeah, up 4 over 2. Yeah, up 4 over 2. So that's slope of 2. So there's 2. E to the 2 minus 2, that's e to the 0. Anything to the 0 power is 1, right? So e to the 0 is 1. 1 times 1 is 1. 1 minus 1 is, well, sorry, 1 minus 0 is 1. So 2 over 1. That's a real number. So that's our limit. Now, there's something a little strange about the way AP exam grades, and I just want to let you guys know, especially with L'Hopital's rule, there's an issue with equal signs. So they don't like to see equal signs. So make sure you use arrows. I know that just feels like such a, I mean, okay, this you can do 2 over 1 equals 2, that's fine. But if you're going through L'Hopital's rule process, for some reason, they don't appreciate, yeah, they don't like that equal sign because they're saying, okay, this is not exactly equal. So if you say equal sign, they're going to take that very literally. A lot of times students use equal sign to indicate that they're just showing you the next step, where the next step is. But the way that College Board looks at equal sign, they're looking at it very literally. It's like, okay, is this the same? If it's not the same, then there's something wrong there. I'm going to take off a point there. So typically, I would just suggest, if you're just showing that you want the grader to know that you're moving to the next step, use an arrow sign. If you use an arrow, the grader can never take off a point. They can never say, oh, wait, you're saying these are equal. No, you're just indicating that you're going to the next step. So I know it's such a minor thing to take off points, but it's just one of the things that that they are picky about. So okay. So typically on FRQs, use arrows if you're trying to move along, because if you use an equal sign, they're going to look at that. Yeah, the graders are told to look at equal signs very carefully and compare what's on both sides. And if they're not equivalent, they may take off a point. Okay, so there's more L'Hopital's rule coming, but I want to make sure I went through an entire procedure, make sure that you understand the whole process. Okay. And again, you only do L'Hopital's rule if you see 0 over 0. If you get any other situation, then you stop and you just present your answer. It's either a real number or limit doesn't exist, but you only do L'Hopital's rule if there's an incomplete process. Okay, so let's go to page 11. Let me see. About this, let me have you guys do 11 and 12 for homework, and let me try to do 13 and 14, because 13 and 14, this is more like what your quiz will look like. It'll be a table and a graph, and I just wanted to spend time in class going over, and then but 11 and 12 is good, but I think that you guys do that for homework. Okay, so your homework is 11 through 14, so we're going to try to get through half of it. Okay, so very similar. You have a table, you have a graph, you have f is defined as a cosine 2x. G is a differentiable function, so that just means a smooth curve all the way through. There's no hidden holes or asymptotes in between. And then h. Okay, h is given in the graph above. Okay, part A. Part A says find the slope of the line tangent to the graph of f at x equals pi. Okay, so just like yesterday, to find well, here it's only asking for the slope. So to find the slope, I just need to find the derivative. To find the derivative, I just go through my derivative rule. Okay, so cosine of u becomes negative sine of u times u prime. E to the u becomes e to the u times u prime. Okay, so as you guys try it, I'll also put the work down. So I am going to talk through the steps before I do it, but then once we talk through the steps, we'll just work through at the same time and just have you guys practice the process. All right, sine of 2 pi is just 0, so that's just going to 0 out. Sine of pi is also 0. But cosine of pi is -1. I get 0 minus 1, it's just -1. Okay, part B. Let k be the function defined by k of x equals h of f of x. Find k prime of pi. So look at how this is set up. We talked about this yesterday. If I want to find the derivative, what rule is required here? Chain rule. Yep. Outside derivative times inside derivative. So go ahead and build your derivative function first, and then you can involve pi. Okay. Okay, so when you're doing chain rule, you really have to take things one at a time. Okay, so you can't just find something all in one go. Especially with something that looks complicated as this, you do want to kind of find information one at a time, and then I'm going to focus on finding f of pi first. So I have to go to my function here and actually find f of pi. So f of pi, I have to take the time to actually insert pi into f, get that y value. Cosine of 2 pi is 1. E to the sine of pi is 0. E to the 0 is 1. 1 plus 1 is 2. That's going to go here. Okay, so one piece at a time. So I'm down to two things I'm looking for. I'm looking for h prime of 2, which I can grab from the graph, and the f prime of pi, we can pull that from what we got from part A. Right? So h prime of 2 there's h of 2, but that's not what I want. I want h prime of 2. So I need to find the what of this line. Slope, right? So I'm gonna pick 2 points. That's easy to identify. So I'm just going to go from this end to this end. What's my slope here? -1 over 3. Yeah, -1/3. Right? It's hard to find the slope somewhere in between because it's not lining up on an order pair that we can identify. But we can always just pick points that that it actually does land on, and we can count the slope. So down 1 over 3, -1/3. Okay, so more practice with chain rule there. Okay, any questions here? Okay, part C. Let m be the function defined as g of -2x times h of x. It's asking for m prime of 2. So to find m prime of 2, we first have to find m prime of x. To find m prime of x, look at how this is set up. We have to involve what? Product rule, yeah. Product rule and a little bit of chain rule, right? A little bit of chain rule here. Okay, so we're going to go through the product rule. Let's build that out. Okay, so I'm going to call whatever I see first as my f, whatever I see second as my g. So my first function's derivative, g of -2x, is basically g prime of -2x times what? Times -2. Yeah, I got to do a little bit of chain rule there. It's not just an x. I got to take care of that inside function's derivative there. Okay, times the original second expression. Back to the original first. And then h just becomes h prime. And now I can replace every x with what? 2. Okay, so g prime of -4, I go to my table. G prime of -4 is -1. H of 2. Yeah, that's actually kind of, it's not, oh, we know that it's going down by 1/3. So we know this is -0, -1/3, -2/3, -1. So that's kind of, having to kind of figure out what that pattern is for that order pair there. So -2/3 there. Okay, g of -4. Go back to my table here. G of -4 is 5. h prime of 2, we already know h prime of 2 is the slope of this line segment, which is negative 1/3. Okay, so just have to combine all this together here. So this is 2 times negative 4/3 minus 5/3 negative 9/3, which is negative 3. Okay, is there a number C in the closed interval such that G prime of C is equal to negative 4? So we have a bunch of order pairs at the G level. So this is another application of mean value theorem, right? We're trying to guarantee a slope. If I can show that the slope between the endpoints is negative 4, then I know that there must be a point on the graph of G where the slope is exactly negative 4. So we go through our formula here. What are our A and B values that we're going to use? Yeah, A is -5 and B is -3. So we're just going to insert -5 and -3 in for A and B, use the table to get it down to a slope. And if we can show that slope is going to match -4, then we know there must be a specific slope on the curve that is also showing -4. But basically, if I can show that the endpoints produces a slope of -4, then there must be a point on the curve where the steepness is exactly -4 as well. Okay, and if those work out, g of -3 minus g of -5, that's 2 minus 10 over 2, which is -8 over 2, which is -4. Therefore, there's at least one value where g prime is equal to -4. G prime of c equals -4. Okay, next page. Okay, we have a new set of tables here. Okay, let's talk through this, and then I'm just going to work through the same time that you guys work through, just so we can do some practice. Okay, so here, part A, let k of x equals f of g of x, write the equation of tangent line. So ultimately, we have to find what and what. Order pair and slope. So order pair, just plug 3 in, use a table to find that order pair. To find the derivative, we have to again go through chain rule. Okay, good. So we'll find order pair, we'll find slope, point slope form. Okay. Part B, h equals g of x over f of x. Find h prime of 1. We want to evaluate the, find the derivative and evaluate the derivative. Look at how this is set up. You have to go through what? Find the derivative. Quotient rule. So find quotient rule, then put 1 in for all the x's, then use the table to get it down to a value. Okay. Part C, we have to evaluate this antiderivative. We talked about this. We have to go through what? Substitution. Yeah, that 2x we got to do. It's not as clean as just taking that f double prime and making rise up to f prime. That 2x is gonna, we got to keep track of that somehow. Okay, so we should recognize these processes. So let's just practice going through this these problems. the trouble that students run into with chain rule is getting a little muddied in terms of their steps here. So just be clear, right, that you gotta do one thing at a time. I gotta find G of 3 first. G of 3 gets replaced with a number, then I can turn around and find F prime of 6, then I can make it down to 5, right? So sometimes students get a little bit lost in this process, so let me know if you have any questions about that. Part B, I think what can be confusing is that your G and F are flipped around, so everything feels a little bit backwards with quotient rule because we use F and G for quotient rule naming as well. So just be aware of that. Okay, tomorrow I'll check pages 11 through 14. All right, come up with your phones. Your Second period and advisement are going to be merged together, but the rest of the school day, felt good, going to be the same. So none of the other periods will be affected except for second period. No advisement today. Second period is going to merge, with advisement. Mhm.
Is this like, we just, this week, 13, 14, all this stuff?
Yeah.
Is that all like the conference?
Well, tomorrow we'll do. It's fun and fast, but, I'll do the morning review, which is, has been more than is needed, but it's like, if you do the morning review.
Okay. I can give it to you.
Yeah. Or you can put something. Okay. Yeah. Thank you. No.
Okay.
You're good, yeah. 70%. Okay, thank you. Yes. Good, thank you.
I did all of this.
Give me something, that's what you showed me. Sets me today.
Yeah. It's so bonus. Yeah. I was like, I just don't understand why this. But then also, it did this wrong. Because I don't know how to do this. And I saw a lot. So yeah, are you gonna have morning party tomorrow or Friday? It's 106. Yeah. Okay, so. Well, see, these ones that are highlighted, those were the only two things.
Let's see, tomorrow, like Friday, I'll send a reminder today, to let you know.
Because you have to go down. It's literally like. It's kind of like a hospital. He's on this.
Sure.
Oh, okay, so nice.
Yeah, for B, yeah, I'm not holding the key and go through with you.
What?
So, there's term restrictions when L of T is greater than or equal to 150. So
they're saying that they want to have restrictions when there's more, wait. When the amount of cars turning left.
right,
I guess the
because,
logic is.
well, because basically they want to be include a traffic light because there's so many cars turning left.
Okay.
So L of T is greater than 150. So if you look at the graph here, greater than 150, it's gonna be somewhere in this range, right? Somewhere in that 12 to 17 range. But we want to kind of figure out where that line is. You can graph both L of T and 150 and see where they intersect. But I find the easier thing to do is rather than looking for the intersection in such, large value that's hard to find. What if I did L of T minus 150? And what if I just graph this function instead and look for the x-intercept? And if I graph this and look for the x-intercept, I will still get the same answer. It's just a little bit easier to find because I'm just searching along the x-axis. So I'll get 12.42 and 16.12.
So, okay. So it's saying find all values of T for which, I think I'm struggling with the comprehension,
Got it.
getting it
Yeah.
through, so.
So, all right, guys, see you tomorrow.
Compute the average value of L. I
So,
think that's.
okay, so
where I get
first,
confused.
let's figure out the, where L of T, this is L of T, is greater than 150. So there's, all these are indicating how many cars are turning left. So at what time are the cars turning left more than 150? Correct? So
Okay.
there's 150, right? 150 is here.
don't have to get like.
Okay, so it's saying more.
So we're expecting somewhere in that 12 to 17
Yeah.
range. In those hours, that's basically rush hour. Rush hour, there's going to be most number of cars turning left per
Okay.
hour. And that's asking, what is the average rate at which, what's the average amongst all these values? So basically you're going through average value theorem. But to do that, you first have to figure out where these endpoints, so these intersections are. So basically we need to figure out when is L of t, the curve, equal to 150 to find that intersection.
Okay,
So
so,
I can, one thing that I can do is I can, yeah, you got this all typed in. You can have all this equal to 150, right? Graph both these lines and see where those intersections are.
okay, so if you graph 150, then you can do what? You can do the intersect thing.
Yeah, but
Okay, I think
but-
that's what makes more sense to me.
okay, but if you do that, you're gonna have to adjust your window because your window is not gonna
Right.
see everything. So, I mean, this is all the way up to 250. You can do that. Y max at like 300. And we definitely want to extend out to, let's say, 20. Okay,
Mhm.
okay, so we should be able to see it. Yeah, that works. So if you do intersect at these 2 points, you'll
Okay,
get 12.42, 16.12.
okay,
But the way that I was doing it was I was doing L of t minus 150. I was graphing this.
so you were graphing it, that's where I got confused, because
Uh-huh.
I was trying to solve it by hand, I think.
Yeah, you don't want to solve by hand. This is meant
Which
to
is
be
what
this is meant to be a calculator question.
So.
So they
yeah,
want you
and
to.
then what the answers, which I don't know, how I got those. So you said you're graphing it? How do you, I'm confused why you graphed that.
Because this is the same equation, right?
Okay,
Same equation. Okay, so let me show you. The reason why this feels messier is because you have to adjust your window. You got to find the intersection. But let me show it to you from this perspective. So I'm not going to type this in again. I'm just going to call y1. Y1 is LT. So if I do y1 minus 150, okay?
okay,
And this is the same equation, but rather than looking for intersection, I'm just going to look for the zero.
okay,
But I should come across the same answer. So I'm going to graph this. But if I graph it, I only highlighted that, so it's only going to show that to me. I'm just looking to see where the graph crossed the x-axis. Now, I do want to adjust it because this is harder to see, so I'm going to do this.
okay, so all it did is it took the graph and it made 150 the x-axis. It took it down, so you can then find the x-intercept.
Intercept, yeah.
Okay, so
yeah.
okay, so it just made that, okay.
That's, yeah, and so here, if I did from negative 10 to 10, or negative 20 to 50, for instance.
Second period, I have to go to.
Okay, but it's essentially the same thing, x-intercept there. Okay. Do you know if she has?
This is yours.
This is mine, okay.
Yeah, maybe if you write me.
Okay.
Just in case, I'm gonna write down here though, so it probably won't matter. Thank you, and you said, or when did you say there was help? I needed to come in and ask questions, but I just always get distracted.
Yeah, I'll do tomorrow morning and Friday morning. See you tomorrow.